Hey, welcome to the lesson where we're going to be solving square root and other radical equations. How can we use our knowledge of radical expressions to now solve radical equations? So by the end of the lesson, you should be able to solve radical equations, then combine expressions with rational exponents, and simplify expressions with rational exponents as well. The first example is the square root of x minus 1 equals x minus 7. So as long as I have the radical on one side by itself, I can square both sides. That's the inverse of a square root. Therefore, if I square a square root, I will essentially cancel out, or I will undo both of those functions, or those operations. So I will be left with x minus 1. Now make sure that you also do x minus 7 squared. Make sure you square the other side as well, because it is an equation. What you do not want to do, do not make this mistake. This is a very common mistake. Do not make this mistake. Don't do it. It's completely wrong. 2x minus 7 squared is not x minus 7 squared. You cannot distribute the 2, just distribute it in. That is no bueno. Not good. Okay? What you need to do is you need to use binomial expansion. X minus 7 times x minus 7. And now you need to multiply that out. X squared minus 14x plus 49. And so if I have that, x minus 1 equals x squared minus 14x plus 49, I am going to make one side equal to 0. So I'm going to subtract an x from both sides. So I get negative 15x now. And I'm going to add 1. So now I have 50. And now I can use I can use what I know about factoring polynomials to find the factors that would make this equation true. So I need to find what multiplies to 50 and adds to negative 15. Well, that's negative 5 and negative 10. So I have x minus 5 could make the equation equal 0, or x minus 10 could make the equation equal to 0. And so the two values of x's that could make this equation true are 5 and 10. Now, are those my final answers? No, they are not. It is always, 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 always important to check all of your answers, no matter what. When you are solving radical equations, because of this phenomena of squaring a square root, it adds for negative factors as well, but they don't account when you take the square root. For example, the square root of x squared equals negative 3 squared, so x equals 9. That is a perfectly true equation. Now, does the square root of 9 equal, so if I start with my original equation, square root of x equals negative 3. Does the square root of 9 equal negative 3? If we're using just the absolute values, then no, that is not true. So you need to make sure you check all of your solutions. You may get what we call an extraneous solution that will not hold true for the equation. The equation will not hold true if you input that in as x. So let's check x equals 5. If I put 5 in, 5 minus 1 is the square root of 4. 5 minus 7 is negative 2. Square root of 4 is 2. And negative 2. So 2 does not equal negative 2. So therefore 5 is not a solution. It is what we call extraneous. It is an extraneous solution, which means it does not work. Now if we use 10, 10 minus 1 is 9, good. 10 minus 7 is 3, the square root of 9, is that 3? Yes it is, therefore 10 is a solution. So since we know how to combine and simplify and manipulate radical expressions, we can now take that knowledge into radical equations and solving for x. Important thing to remember, make sure you remember this and make sure you do it every single time. Check for extraneous solutions. Go ahead and get started on your assignment. If you have any questions, reach out to me anyway, whatever's easiest for you, phone, BBIM, email. Meet me in Math Cafe Monday, Tuesday, and Wednesday at 11 a.m. If you have any questions, you can also go at any other time from 9 to 3 on a school day, and there will be a teacher in there to help you out. Good luck, and we'll see you next lesson about solving equations with two radicals.